We've been talking about inequalities and absolute value equations. Now we're going to combine the two into absolute value inequalities. Now, what you have to remember is that when you have an absolute value of something less than a number, we're looking at a area inside a particular radius. So we're looking at an and compound inequality. When we have an absolute value greater than some number, we're looking outside, okay? Because we're looking for a distance that's greater or further away than a particular number, so we're looking at an or compound inequality. For example, if we want to solve and graph the absolute value of x is greater than or equal to 6, I'm looking for numbers that are further away from 0 than 6. So I start at 0, and I look to the right, 6 units. Let's go up by 2s. So my center is 0, and I'm looking at 6 or more units away. So 6 is 6 units away from 0, and everything to the right is more than 6 units away. Negative 6 is 6 units away from 0, and everything to the left is more than 6 units away. So again, since we had a greater than or equal to inequality, we're looking at or. So to write the solution of that inequality, we read it as x is less than or equal to negative 6, or x is greater than or equal to positive 6. For a less than situation, such as the absolute value of x is less than or equal to 0.5, we're looking for our distance to be within 0.5. So we mark off 0.5 to the right and 0.5 to the left. And since we're looking at a distance less than 0.5, we want to be inside those boundaries. So we mark our boundaries and we use filled in circles because we have less than or equal to. And we look at all the points between them because those are points that are less than or equal to 0.5 units away from 0. And so to write our compound inequality, we have negative 0.5 is less than or equal to x, which is less than or equal to 0.5. So again, since it was less than or equal to, we're looking at an and inequality. So what we do when we have more advanced inequalities, such as x minus 5 is greater than or equal to 7, is we start by splitting it like we did with our equations. So we know that x minus 5 has to be greater than or equal to 7, or, and we know this is an or inequality because it's greater than, and the negative one always becomes the one with the switched sign. Now the reason is we're looking for points that are more than 7 units away from 5. 5 is our center in this case instead of 0. And so if we started at 5, we'd be going 7 units to the right and 7 units to the left. And when we solve our inequalities, oops, I forgot to put a negative up here. We'd have x is less than or equal to negative 2, or x is greater than or equal to 12. So we've got closed circles at 12 going to the right and negative 2 going to the left. So again, we split into positive and the negative one gets the switched sign. This will be real helpful when we have something with a lot of different parts to it, like the absolute value of negative 4x minus 5. That's real messy. Plus 3 is less than 9. Now we know that since it's less than, we're going to be looking at a and compound inequality. But let's just follow our steps. We would have the absolute value, negative 4x minus 5, is less than 6 after we subtract 3 from both sides. Then, when we take away our absolute value, we have positive 6 on one side and negative 6 on the switched inequality. So when it switches to from less than to greater than, that's where we get our negative symbol. Okay, so that means that negative 4x minus 5 is between negative 6 and 6. Then we add 5 to every section. And when we divide by negative 4, we remember that we've got to switch the direction of the signs because we're dividing by a negative number. And so we'd have negative 1 over 4 is greater than x, which is greater than negative 11 over 4. Sorry, that's positive 1 over 4 because we had a negative divided by a negative. And writing these in order gives us our final solution. Negative 11 over 4 is less than x, is less than positive 1 over 4. And so we're graphing our solutions. We can start at 0, and let's go up by halves. So every half, or every 1 tick mark is a quarter. That's negative 1 half, negative 1, negative 2, or sorry, negative 1 and a half, or negative 3 over 2, negative 2. That didn't leave us with very much room. Let's adjust that to the right a little bit. Negative 1, negative 3 over 2, negative 2, negative 5 over 2, negative 3. So, negative 11 over 4 is halfway between negative 5 over 2 and negative 3. So we're going to have an open circle there, and an open circle at 1/4, and we're looking at the area in between them. So try a couple of those on your own. Let's try x plus 3 is greater than 8, and 3 times the absolute value of 5m minus 6 minus 8 is less than or equal to 13. Pause the video and give those a shot, and then unpause the video and see how you did. So starting with the one on the left, we know that since it's greater than, we're looking at an OR inequality. X plus 3 is greater than 8, and then the negative 1 gets the switch sign. X plus 3 is less than negative 8. We subtract 3 from both sides, gives us x is less than negative 11, or x is greater than 5. So we would have an open circle at 5 with an arrow going to the right, and an open circle at negative 11 with an arrow going to the left. For our blue one, we'd start by adding 8 to both sides, which gives us 3 times the absolute value of 5m minus 6 is less than or equal to 21. Dividing by 3 would give us the absolute value of 5m minus 6 is less than or equal to 7. And then we split, and our negative 1 gets the switched sign. Adding 6 to both sides gives us negative 1 is less than or equal to 5m, which is less than or equal to 13. Dividing by 5 gives us m is between negative 0.2 and 2.6. So if we want to plot those on the number line, we're looking at 2.6 about here, and negative 0.2 about here. And we're looking at the area in between them. So let's take a look at a word problem. You're buying a new computer and find 10 models in a store advertisement. The prices are $890, $750, $650, $370, $660, $670, $450, $650, $725, and $825. The first thing it asks us to do is find the mean of the computer prices, or the average. So remember that we find the mean by adding up all of the prices and then dividing by 10. I'll give you a few seconds to do that on your calculator. So if we add those all up, we get a total of 6,640. Divide that by 10 gives us an average price of $664. Now part B says we are willing to pay the mean price with an absolute deviation of at most $100. How many of the computer prices meet your condition? So remember, our absolute deviation tells us that what we want to pay, the price that we're willing to pay, can be different from the mean, 664, by at most. That means less than or equal to $100. So we solve this inequality the same way we solve the other ones. We split it into plus or minus, and the minus gets the switched sign. Then we add 664 to both sides, or to all three sides, and we get our solution that the price we're willing to pay is between 564 and 764. Alright, if you have any questions, feel free to ask. If not, you can move on to your homework.